Let's solve these three questions. Let's start with this one. Data members and member functions of a class by default are respectively, and they've given us 4 options. Now, in these 4 options, we find 2 C++ keywords. One is private and the other is public. These 2 keywords are our access specifiers. An access specifier will control the visibility of data members and member functions of a class. Now, they've asked that if we do not mention the access specifier for a data member and a member function, what will be the default type? Remember, if the access specifier is not mentioned by the user, then by default it will be private. By default it will be private. That is option D. By default it will be private. But is it desirable to make both data members and member functions private? A class which will have both data members and member functions as private will be practically of no use, because it will be completely concealed from the outside world, and it can not be put to any use because any entity outside the class will not be able to make use of it. So the desirable scenario should be that data members should be made private in order to prevent accidental or intentional alteration to the data, and in order to implement data hiding, which is an important principle of object-oriented programming. And member functions should be made public so that they can serve as an interface to the data members of the class. Coming to the next question. Function overloading is done at, and they've given us 4 options. You can read these 4 options. So let's first understand what is function overloading. Function overloading is the process where you have one function name performing different tasks at different scenarios. Now, how do I make a function perform different tasks at different scenarios? See, if we have one function name and the function name takes in different number of arguments and different types of arguments, or only different number of arguments or only different type of arguments, then it is said to be overloaded. So we can have one function name and we can implement 3 types of it. Okay, it's like having one function name called f and implementing 3 versions of it. Remember, function overloading is a way to implement polymorphism. Polymorphism is another very important principle of object-oriented programming, which states that one entity may have multiple forms. So one function may have multiple forms depending on the scenario. And remember, polymorphism can be implemented in 2 ways or at 2 times. One is compile time polymorphism and the other is runtime polymorphism. Compile time polymorphism is implemented through function overloading and operator overloading. And runtime polymorphism is implemented through function overriding. And out of these options, we find that function overloading is done at compile time. So this is the correct answer. Now, coming to the last question, find the value of I for the following expression. Now, we have been given this expression and we have to do some mathematical calculations. So in order to solve such questions, one thing we could do is look up the operator precedence table, which will tell us the order in which this expression should be evaluated, because we have a number of operators here. As you can see, we have a shorthand operator plus equal to, we have the parenthesis which has the highest precedence among all these, we have the relational operator greater than, we have the conditional operator. The conditional operator is question mark colon. This is our conditional operator, and mind you, this is the only ternary operator available in C++. A ternary operator is one which takes in 3 operands at a time. So we have this ternary operator as well, and along with that we have the logical, not the logical AND, the bitwise AND. The bitwise AND will be performing the AND operation, but it will be done bitwise at the bit level, not at the number level. As in, we won't be considering the number as a whole, but we'll be converting the number into its binary form and then performing the AND operation. So here, if you go step by step, this statement won't be that difficult to evaluate. We find that, okay, I'll just do it step by step for you. Now we have here I plus equal to f greater than 3 conditional then 2 colon 5 semicolon. Now, one interesting thing that you must note here is that this conditional operator always has two parts to it. The conditional operator will always have two parts to it, separated by the colon. This part is called the true part, and this part is called the false part. So if the result of this conditional statement comes out to be true, then this statement will be executed. That means it will come to the true part, otherwise it will come to the false part. And that true part will be assigned to the variable on the left hand side, or the false part will be assigned to the variable on the left hand side. Now, as you can see that the value of f is 11. So 11 is greater than 3. See, 11 is greater than 3, and here we have a conditional operator. 11 is greater than 3. Now, since 11 is greater than 3, it will come to the true part. And what is the true part telling us? The true part is telling us to perform a bitwise AND operation on the values of I and 2. So, what is the value of I? I is 3. I can represent 3 using 4 bits, 0, 0, 1, 1. And what is the value of 2 in binary? But 2 is represented as 0, 0, 1, 0. Now, if I perform an AND, I know that 1 and 0 is 0, 1 and 1 is 1, 0 and 0 is 0, and this is also 0. So, this is my final expression. So, this is 2, right? So, 3 and 2 gives me 2 itself. Now, what am I left with? I am left with I plus equal to 2. Why? Because the true part evaluated to be 2. And as I mentioned that the true part will be assigned to the variable on the left. So, we have I plus equal to 2. Now, what is the value of I? The value of I is 3. So, this will come to be I equal to I plus 2, which in turn will give us I equal to 3 plus 2, that is 5. So, the final answer is 5. That is option B. Right? So, I guess this one, you understood this part. And one more thing before I wrap up, that is, see, whenever you find a conditional statement, the result of the conditional statement is either true or false. That means the result of conditional statement will always be a Boolean value. So it will be a Boolean true or a Boolean false. So if it's true, then you come to the true part, otherwise you go to the false part. Thank you.